Okay, good morning, everybody. So today's lecture is that we're going to put our knowledge of structures and dynamic memory allocation into practice. So we're going to build a simple data structure. So I'm calling this a string, but I mean, implementing a list is basically the exact same thing. Change the name of the functions, but the underlying representation is almost exactly identical to what I'm going to do today. We know that C-style string has a lot of limitations, right? It doesn't know how big it is. If you want to figure out how big a string is, you have to call string length. String length has to iterate over the elements of the array to find the null terminator. That seems wasteful. Many of the functions that operate on strings are awkward to use, right? String cat, you have to be careful to ensure that when you concatenate two strings, there's actually memory for the fully concatenated string. Otherwise, bad things happen. Right? And there's all sorts of other issues that arise when working with plain old C-style strings. So if you're working with strings a lot, or if you want a list, which is also common, you might want to roll your own data structure that represents a string. Right? So for example, that's exactly what Python and Java did, right? And also C++. Right? They rolled their own special string type, and those string types are, I think no one would disagree that they are easier to use than plain old C-style strings. All right, so in Java and Python, a string is immutable, right? So you make the content, you create a string, you initialize its contents, and that's it. You're stuck with that string. If you want to change it, so if you want to concatenate two strings, or if you want to remove a character from a string, you end up creating another string object. In C++, strings are immutable. So you can create a string, and then you can edit the string, that string object to change the contents of the string. And so what we're going to do is we're going to implement a mutable string. So this will be something similar to a C++ string. So not like a Java string or a Python string. It turns out when you go to implement this sort of thing, there's many ways to do this. I'm going to show you the quote-unquote obvious way to do this. You can be a lot more clever about how you do this, and you can get better performance out of your string type if you are a little more clever. If you search online for C string libraries, you'll find several different libraries. Most of the widely used ones are, they do things in a cleverer way than what I'm going to show you. All right, so if we're going to make a string, you need to store some information about the string. So at a minimum, you need to store the length of the string, right? Because we don't want to be doing an ON operation to find out the length of a string every time we want to use one. So an absolute minimum, you need to store the length of the string somewhere. You also need to store the characters of the string somewhere. So you're going to need an array of some kind. And once you're storing more than one piece of information, you might as well put those into a structure of some kind. Right? And so we're going to make a structure. So our structure is going to be called QString, short for Queen's string, I guess. But you can call it whatever you like. So there's our structure. Now we're going to put that into a header file somewhere. Right? And so the declaration of the structure goes into a header file. When the user wants to use your string, they just include your header file, and away you go. All right, so we want to record the length of a string. So at a minimum, there's going to be a field that represents the length of the string. Right? The length is an unsigned int, right? It's never negative, so it makes sense to use an unsigned type in this case. I'm using size t here to represent the length, but you could use unsigned int as well, and everything would probably be fine. That would let you store pretty big strings on most C implementations. Unsigned int, yes, so 2 to the 32 characters in a string, which is pretty big. All right, so we're also going to use an array of char to hold the characters of the string. A more sophisticated implementation of a string might use an array of different type to represent a wider range of characters. Right, so remember char on most C implementations, 8-bit, so you get 256 characters. If you were doing some sort of multilingual string, you'd want to use a bigger type. What else do we want? Oh, so we need an array. Now, if you want to, so let's see, what's the best way to put this? All right, so if you want your string to be mutable, you want to be able to do things like concatenate two strings, changing the length of one of the two strings, right? So if you want to do that, you can't make a fixed size array, right? So you're not allowed to make it, because that won't work, right? Because you're going to have to resize the array if you don't have enough room to hold the full string, the fully concatenated string, right? Similarly, if you want to insert characters into the string, again, you might have to resize the array at some point, so you can't use a fixed size array, right? So the only way to reallocate storage is to use the realloc function in C. So your array here can't be a fixed size array. It has to be a dynamically allocated array, right? There are other reasons why you don't want to use a fixed size array here, right? If you're passing around QString objects by value and you have a fixed size array, you also pass the array around by value. So you copy all the elements every time you want to pass that string to something. So we're going to use a dynamically allocated array to store the characters of the string. Finally, if you want to change the size of the string, you need to know not only its length, right, but you need to know how much room is there in the array. Right, so the length field here is not the size of the array, it's the number of characters in the string. Right? Length will be 0 if you have the empty string. If you want, if you want to, when you're resizing the array, you need to know, is there still room left in the array to store some extra characters? So you also need to keep track of the capacity of the array. Right? So capacity, that's how big your array is. Length, that's how many characters are in your string. Right? And finally, we're going to store the null terminator in our array so that that thing there is a proper C-style string. The reason you want to do this is because you might want to use the other string, the standard string functions provided by the standard library. Right? So for example, you might want to print a string using printf. Right? There's no way to print one of these using printf. Right? So you might want to just hand it the pointer to the internal array so that it can print that string like it was a regular C-style string. So it's, in our design, we're going to make sure that that thing there is null terminated. Right? So car data, dynamically allocated, null terminated C-style string. Capacity, how much room is in the array pointed at by data. Length, how many characters are in the string, right? Not including the null terminator. So there's our structure for a string. You can do the exact same thing if you want to make an array-based list. Right? So for an array-based list, you'd make a dynamically allocated array of the element type for your list. Right? So if you wanted a list of double, that would be double star data. Right? Capacity, how much room is there in your array? Right? Length or size, how many elements are in your list? Right? Okay, so once you make the structure, you're good to go. Right? You can actually use that thing the way it stands. Right, so there's my QString structure there, and there's a little main method, a main function that uses our structure. Right. Okay, so we're going to start by making a pointer to a QString object. So you might wonder why I just don't make a QString object without. So why am I using a pointer, or why am I doing dynamic memory allocation instead of just making a QString object? So you can just make a QString object here, right? You can just write struct QString s equals some QString, right, or nothing, and then fiddle around with the members of the structure, right? But here I'm going to dynamically allocate one. One, so that we can actually practice doing some dynamic memory allocation, and two is because this is normally the way you're going to do things when you create your own types of data structures. Right? It's the normal thing to do is to pass around pointers to your objects instead of passing around your objects directly. Okay, so allocate a new QString and keep a pointer to that QString object. Right? So now if I want to use it for something, like if I want to store a string in this in the array, I need to do things like, well, first of all, I need to allocate a new array. Right? This only allocates a structure. So I have a length, I have a capacity, and I have a pointer. I don't have a pointer to I don't have an array yet. So now I have to go and allocate that array. Right? So for the data array, I want to allocate an array. It looks like I want to make an array of length 8. Sorry, size 8, or capacity 8. Let's work with capacity. Right? And so I also have to remember to set the capacity member when I do this. Right? So set the capacity of your structure, go ahead and allocate an array to store 8 characters. Right? And now I can fill in the length, I can fill in the characters of my string. Right? So here I'm using printf, or sprintf. Sorry, I don't know what's going on. Probably a bad USB connection. Oh. All right, so I'm going to use sprintf to print the string sys220 into my array. You could manually go in, set the individual elements of sdata yourself. Right? sprintf is easier in this case. You could also use, what else could you use? You could use, can you safely use strcat in this case? No, you can't use, so when you allocate the array, right, you have to remember that the array is not 0 initialized if you use malloc. Right, and so what does that mean? It means if you try to treat the data or data as a proper C-style string, it isn't. Right? There might not be a null terminator anywhere in that array. So you can't safely use functions like stringcat to write sys220 into that array. Right? You can use sprintf though. That'll work just fine. Right? Sprintf doesn't necessarily print into sprintf prints into an array of char. It doesn't print into a string. Right? So once you've printed the string into the array, you now have to remember to set the length. Right? If this is all very, if this seems to be all very tedious, it is because it is. Right? So every time you do something with your string, right, you might have to fiddle with the capacity, you might have to fiddle with the data, you might have to fiddle with the length. Right? And that's not only awkward to use and inconvenient, it's also very error prone. Right? It does work though. So if you actually run this program, it does what you want it to do. Right? It does in fact represent the string sys220. Right? If you wanted to, you could look at its length and its capacity. Right? And everything works just fine. Okay, so notice that when you're done with the string, right, you have to remember that you've malloced or allocated 2 things. Right? You allocated the structure, right? And internally, you allocated the data array. So when you're done with this thing, you have to deallocate both, and you have to do it in the right order. Right? You can't deallocate the structure first. As soon as you deallocate that structure, S is no longer a valid pointer. If S is no longer a valid pointer, you can't get to the data array to deallocate the data array. So when you deallocate the memory, you have to do it from the inside out. Right? So we need to deallocate the array first, right? And then you can deallocate the structure Right? Okay, so when you're working with the data array, right, it's a dynamically allocated array, right? And so our string type, or when you're working with the string, it's your job to make sure, well, if you're going to work with it in this way, right, with a plain old structure, then it's the programmer's job to make sure that the data array is always valid, right? Furthermore, that array has to be reallocatable. If you want to increase the size of the string, right, you need a bigger array now, right? So you need to make sure that however you're working the string, you can reallocate it using realloc, right? And finally, you've allocated some memory, so if you're going to implement it this way, you have to make sure that you can free that array as well. Right? So here's an example of what you must not do. Right? Exact same structure, allocate the structure, right? Boop, 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 set your capacity, right? And now you go ahead and make a local array, right? So you make a local array of length 8. So that buffer array has capacity to hold 8 characters, right? And now you do something that you shouldn't do, right? You say, well, data is a pointer, so I can just make it point at the array buffer, right? So sdata equals a pointer to the first element of buffer, Or if you like, you can just write buffer here. They both do the same thing, right? And now what's your problem? Well, your problem is your data array is no longer dynamically allocated, right? So here we have a function called badString, right? What does it do? It returns a pointer to a newly allocated string, right? What's the problem with the newly allocated string? Right? Internally, it has a pointer to a local array. That local array doesn't exist after the function returns. So if anybody who tries to use the array that's inside the string is going to have a bad time, right? So that's the exact same example. It's just I've pushed everything into a function now, right? So now in the main function, I call badString, right? I get a pointer to a dynamically allocated string, right? I'm going to try to print the string that's stored, or the data buffer that's stored in my string. Now in this example, I'm pretty sure it usually works on my computer. So it does something. Oh, no, oh, it does print the string, right? Which is funny, but it does seem to work in this case, right? So it looks like I can safely print the array, right? Even though technically the array no longer exists, right? But when I try to free that array, that's when you get a problem, right? Now you see there's a double free error, right? And you might say, we might wonder why is there a double free error? I only called free once, and it's true, right? But this array went away when the function went away because it's a local array, right? It has automatic storage duration, and so its memory automatically gets freed when this function is finished running, and so the library seems to think that this is a double free or a corruption bug, right? We've tried to free an array that you aren't allowed to free, which is exactly what's happened in this case, right? And so now you have an error, right? So never, ever, right, set your data member to point at a locally or to point at an array that has automatic storage duration, right? That array always must be allocated using dynamic memory allocation. All right, so so you could use the structure the way it stands. It's super awkward to use the structure the way it stands, right? It would be much more convenient if we wrote a bunch of functions that did a lot of these tasks for us. So if we want a new string, it would be nice if there was a function that gave us back a new string. If we want to concatenate two strings, it would be nice if there was a function that concatenated two strings. Right? So when you do this sort of thing, so when you make a data structure, typically what happens is you define the data structure, the information for the data structure. Often it goes into a struct. And then you also define a bunch of functions that operate on your data structure. Right? And so this is very similar to what you did in 124. Right? So in 124, when you make a class, right, you decide what fields go into the object. Right? That's your data. Right? You also provide some constructors to initialize the data, right? And then you provide some function or methods that operate on the data. So it's the exact same thing in C. It's just the mechanism that you do, the mechanism that you use to define the quote-unquote constructors and function methods are different, right? In C, all you have are functions, so our constructors and methods will also be functions. All right, so if you're making a real string library, chances are the number of functions you'll put in it are very large. We don't want to do that because we don't have time, and it's also going to get very boring very quickly. So we're going to make a general purpose string library, but it's going to be quite small, so it'll have a relatively small number of functions. Right? We want to be able to make a new string conveniently. So it'd be nice if we didn't have to allocate our own structure, allocate our own array, set the size and capacity, or set the length and capacity of the structure every time ourselves. So we've got a bunch of functions here that'll do that for us. So we have QStringNew, that makes a new empty string. If you're making a string, you probably want to be able to make a string from a C-style string. So QString from C-string makes a new C string given a C-style string, right? And you can imagine there's a whole bunch of other functions here that you might want to include as well, right? You might have a function that creates a new string and that string is guaranteed to be able to hold a string of having some specified size, and so on and so on and so forth. Right? You might want another function that makes a new string given several C-style strings, right? And it joins them all together for you. Those all might be very convenient. So new, anything with a new in it. The new and from C string, these are like similar to constructors. Oh, we have another one too, QString copy. Right? This is similar to a Java copy constructor. Now remember, these things aren't constructors, right? C doesn't have constructors. So these things are all functions. Right? QString copy makes a new QString by copying an existing QString. Right? Okay, we now have a bunch of functions. So once you're given a string, you might want to empty out the string. So you might want to make it the empty string. So that's what QString clear does. Given a string, you might want to be able to get a character from the string, right, by index. Right? So similar to char at in Java. So there is QString get. QString set sets a character in the string. QString assign overwrites an existing QString with the contents of another QString, right? So that's something that would be like assigning a variable, right? So if you have a string s and you want to do something like s equals t, right, and have proper assignment semantics, right? There you have. So here you have to use a function to do that, right? So you call QString assign, right? That writes. That overwrites the left-hand side, the string pointed at by left-hand side with the contents of the string pointed at by right-hand side. Right? There's concat, so we can concatenate two strings. And this one returns, to the end of, okay. So concat concatenates onto the end of LSA, the left-hand side. Right? So you pass in two strings, it'll concatenate those two strings, storing the result in LHS, the left-hand side. Unlike str concat, our version of concat, you can concat a string onto itself. Right? And finally, we've got remove range. So that removes a range of characters. So basically, it removes a substring from a string. Right? You pass in a string. Right? You say what character do you want to start removing from? Where would you like to stop? And it removes that chunk of characters from the middle of your string. All right. So notice that new from C string and copy and several other functions all return newly allocated QStrings. Right? So if you're going to return a newly allocated QString, you need a way to free the allocated QString. Right? So you have to remember, well, I have to free the underlying data buffer and I have to free the structure itself. Right? So instead of forcing people to free both things every time, it makes sense to provide a function that does the freeing for you. So destroy deallocates the memory used by a QString and also frees that pointer there. Right? Okay, so all of our functions return pointers to QStrings, right? And they all take in arguments that are pointers to QStrings. Right? You don't have to write it this way. Right? You can write functions that return QStrings and take in QStrings directly. The problem comes later. So later when I tell you about these things called opaque types, you can't do that anymore. It doesn't work the way you want it to. So most of the data structures that you end up defining, so if you write a library that you intend other people to use, right? Your library provides the implementation of some kind of data structure. So a list, a string, stack, queue, something like that. Typically you implement it as an opaque type. When you implement it as an opaque type, your only choice is to return and pass things in by pointer. So I'm just going to start doing that now. The added benefit is you get used to working with pointers as well. Right. There's another advantage to, there's another side effect of returning pointers to stuff. Right? If something goes wrong in the function, sorry. Oh. Okay, so if something goes wrong in the function, so for example, if new can't allocate enough memory for a new string, that gives you the ability to return null from the function. Right? So returning null from a function lets us indicate that something has gone wrong. So remember that C doesn't have any exceptions, right? Or it doesn't have any built-in exceptions. So there's no way that you can throw an exception to indicate that an error has occurred. Right? In C, what ends up happening is you either return something from a function to indicate an error condition, right? Or you set some variable somewhere that indicates that an error has occurred. Right? So our strategy is going to be return null if something goes wrong. Oh yes, also notice that our functions have a funny name. Right? Everything has QString underscore in front of the function name. Right? Why are we doing this? It's because in C, all your function names have to be unique. Right? So if I just called it concat or assign, right, and you're using somebody else's library or you've written your own code, right, there's a non-zero chance that you've written a function named concat or you're using a library that has a function called concat in it. Right? So we need some way to make our function names sort of unique. Right? There's no guarantee that these are going to be unique, but we want to make them as unique as possible. So I'm appending QString underscore in front. This is a common strategy again for data when you're writing libraries. Right? You give your library a name, you append the name in front of all of your functions. Okay, so we're going to put in these functions, or we want to make these functions available to users of our type. Right? We have to make them usable to make the functions usable for users of our type. We have to put them somewhere, or we have to declare the functions so that the users know the functions exist. Right? So where do you put them? Well, you put them in the header file. Right? What does your header file look like? Well, your header file always starts with an include guard. Right? So there's our include guard for our header file. Right? Made up of the if and def and the define. Right? Don't forget the end if at the very end is a long header file, sorry. Right there. Right? The contents of the header file. So ours includes the definition of the structure. Right? So our structure is both declared and defined at this point. Right? Anybody who uses this header file can look in and see that there's a length, a capacity, and a pointer to the data. Right? Similarly, anybody using this header file, right, once they get a pointer to a QString object, right, they know they can go in and fiddle with the length, they can fiddle with the capacity, and they can fiddle with the data. Right? So this is an example of an open structure, right, or an open data type. Right? If someone wants to, they can put the string into an invalid state. Right? So you can make a string, it's the string hello, they can go in, set the length to 0 if they wanted to. Right? Or they can set the capacity to 0 or some other value. Right? So this is open type. Right? So C has no access modifiers like Java has. Right? Remember in Java, if you were making a class, you would make these all private. Right? And then anybody outside the class wouldn't be able to modify these values. Right? No access modifiers in C. We've defined the structure in the header file, so anybody can go in and fiddle with the fields or the members of your structure. Right? All right, so we have a constant here whose value is 8. Right? I guess that should have been declared const as well. That really should be declared const. So this is the default. Oh no, it doesn't have to be declared const. This is the default capacity of a newly allocated and empty QString. Right? So if you call new, QString new, you get a string whose capacity is 8. Right? It's not declared const, so someone can change this value. So if they want a different default size, they just go in and change this value to something else. Right? And now you simply declare all of your functions. Right? You don't define them in the header file. Right? So new is declared like that. Right? From C string is declared like that, and so on and so on and so forth. Right? C has no standard documentation format. And so here, I just have some comments that describe what the functions do. Right? So C doesn't have anything like JavaDoc that mandates how you document your functions. And so often what you'll see is you'll just have some comments that describe what the functions do. Some commenting formats, there is some kind of structure, right? So they'll describe the return value, the parameter types, and what the function does. But there is no standard in C, right? And so you just declare all of your functions, and away you go, right? So there's your header file. Once you've got your header file, you can now start to implement the structure itself, right? So in a separate file, so in qstring.c, this is where you start to define the functions that you've declared in the header file. Right? Okay, so in your source code file, right, what do you do? So first of all, you have to include, well, not first of all, sorry, somewhere you have to include, or you're going to want to include, your header file for your type. Right? Why? Because that's where the structure definition is, and that's where all of the functions have been declared. Right? So you want to include that somewhere. When you include your own header files, right? The header file name goes inside of double quotes. Right? The angled brackets, these are reserved for the standard library header files and any of the operating system header files. So when you use the angled brackets, your compiler looks in in a few particular places on your operating system to look for those header files. Right? So in other words, it knows, or it looks in the standard places for string.h to include. Right? When you're including your own header files, you're not placing those header files in any one of the standard locations. Right? Sorry. So you include them with the double quotes instead. You can tell the compiler where to look for your own includes, right? One of the directories that's normally included when it searches for this header file, a header file included with double quotes, is the current working directory. Right? Okay, so we have a bunch of other includes here as well. We're going to use assert for some of our error checking. Standard IO for printing and printing stuff, I guess. Standard lib for malloc, and string in case we need to, in case we want to make use of any of the string functions. In particular, we're going to make use of memcopy and memmove. All right, so you've included your header files. You can now start to include your implement your functions. Right? So our first function is, so we're going to implement the functions that allocate or initialize new string objects. Right? So qstring new should return a new and empty qstring. Right? Now all of these functions, they basically do the same thing. Right? They're all going to return a pointer to a newly allocated string. So internally, we need to allocate a new string object. Right? In fact, that's probably the first thing we're going to do. Right? So malloc a new string, right? Don't forget, when you malloc the string, you also have to allocate the data buffer. Right? So malloc a data buffer as well. Right? What else do we have to do? Well, our string has a bunch of other members, so it's got a length and a capacity. So we better set those as well. Right? The ones that, so if you're going to copy a C string, or if you're going to copy another Q string, you're going to have to copy the characters, right? Either from the C string or from the other Q string into your data buffer, right? And then you want to return a pointer to your newly allocated Q string, right? Okay, so it turns out that allocating the memory for the string object itself and allocating the memory for the buffer, these are going to be operations that we're going to repeat over and over and over again. Right? Many of the other functions that we're going to provide also require either reallocating the data buffer or allocating a new string. So rather than repeating those operations over and over and over again, it makes sense to internally create another function that does the allocation for us. Right? So internally, what we're going to do is we're going to create a function called alloc that allocates a new QString object, allocates its buffer, returns a pointer to the newly allocated string object. So how do you implement this? Well, you've already seen the implementation earlier. right? So when we did it manually inside of the main function, you're basically going to do the exact same thing, right? So we're going to allocate a new QString object that can hold at least that many characters in its string, right, in its data buffer, right? So what do? Well, step one, allocate the structure itself, right? So call malloc, allocate enough memory to hold one QString structure, right? Okay, we've called malloc. If you want to, you can check whether or not malloc succeeded, right? So here I actually put the check in, right? Even though I told you that you probably don't need this check in Linux, or you probably shouldn't do this check in Linux, right? A lot of people will expect you to either know how to do this test or to do this test anyway. So it's inside the notes, right? So if the return pointer is null, you've got an error of some kind. Our strategy here is just going to be print out an error message and then return null, right? Okay, so we now want to allocate the array sitting inside of our newly allocated QString queue, right? So we're gonna use calloc to allocate the array. The advantage of using calloc in this case is that the array gets initialized to all zeros. So if someone tries to use the array immediately as a string, they get an empty string, right? The first character in the string is the value 0. So that looks like, so to the C libraries, that looks like an empty string. So that's nice, right? So to use calloc, you specify how many elements, yes, the number of elements that you want to allocate and how big each element is. Ours is an array of car, so the size of each element is 1, right? And we want to allocate capacity number of elements. Remember, when you call calloc, you're not supposed to allocate 0 bytes of memory. So if someone uses a capacity of 0, we fix it, set the capacity to 1, right? But we don't indicate an error. All right, so we've called a memory allocation function. So again, I'm going to check, did it succeed, right? Now, if it didn't succeed, you have to remember that a previous memory allocation in the same function did succeed, right? So when we allocated the structure, that was successful, right? It's not until we tried to allocate the buffer or the data array that we have a problem, right? So if you run into a problem allocating the data array, you had better free the structure, right? If you don't free the structure, there's no way, we're not going to return the structure back to the caller, right? We're going to return null. So if you don't free the structure, right, you've got a memory leak, right? This structure will never be freed if you don't free it now, right? So this is one of the challenging parts in C, right? Is that once you take control over memory, right, it really is your responsibility to manage the memory. So here we have to remember to free the allocated structure, right? Then we can print our error message, and then we can return null to indicate an error has occurred. Okay, only after we've managed to do all of this can we go ahead and set the length to 0, right? So we have a newly allocated string, its length is 0, right? Its capacity is whatever capacity the caller asked for, right? Our data buffer, or our data array, now points at the newly allocated buffer here, right? Again, that's a dynamically allocated array. It's not a local or an array with having automatic storage duration, right? And finally, we can return Q, right? And so now it should be obvious why we made a function to do this, right? If we have to repeat this operation over and over again, right, you don't want to have to type in this code over and over and over again, right? It's much easier just to call alloc every time we need to allocate a new QString object. All right, any questions on allocating the QString itself? Right, so remember, allocate the object, right? And then whatever memory you need to allocate internally for the object, go ahead and do that, right? So here we have to allocate the its internal array. Okay, so anything marked with, anything marked with a comment has an accompanying note in the notebook, right? And so I think I've covered all of these already when I talked about implementing the function. So if you need a reminder, it's right there in the notebook. Okay, now that you've got alloc, those three functions that allocate a new string are dead easy to implement. Right? New makes a new string. It's empty. Right? So just call alloc. Oh, sorry. Call alloc. Right? And pass in some capacity. So here it makes sense to use the default capacity, right? Which in our case is 8. Right, so that gives back the caller a new string that can hold up to 8 characters, right? 7 plus the null terminator. Okay, what if you want to make a Q string given a C string, right? So I want to make a Q string, it holds all the characters of a regular style C string, right? So what you want to do is you want to allocate a new Q string whose capacity is the length of the C string plus 1, right? So here's our C string coming in. It gets passed in as a pointer to car. Right? We need to know how long is that string, right? Or we want to know how long is that string, right? So call string length on the string. That tells us how long the string is, right? We can now ask alloc to allocate a Q string that can actually hold S, right? So we need to pass in the length of the string plus 1 because we need to null terminate the string, right? So don't forget to do that, right? If this succeeds, right, we have to remember that we have to remember to set the length of the string, right? So our length now becomes the length of the string S, right? We now have to copy the strings from S into Q, right? And so here string copy is perfectly suitable in this case, right? So string copy the contents of S, right, into Q's data array, right? And once you've done all that, you can return Q. Right? You could also use sprintf here. That would work fine, right? So sprintf q data s works. Sprintf q data double quotes %s comma s, right? Would work just fine. String cat also works here if you wanted to do string cat, because we know because our array has all zeros in it, right? So that would work just fine as well. Any questions so far? All right. Copying a existing Q string, right? So I want to copy an existing Q string. So here I do a little bit of error checking, right? So if the incoming Q string is null, then we simply return a new empty string, right? You could also return null here to indicate that the function has been called incorrectly, right? I've decided here to simply return a new empty Q string. I want to now allocate a new string that can hold the contents of S, right? So here I can just simply copy S's array, right? So I want to allocate a new Q string that can hold the same, that has the same capacity as S, right? If that works, I now want to copy the contents of Q strings array into this object, right? So I could write the code to do that. But if you remember, we're going to write assign later on, right? And assign does exactly this operation, right? It assigns the contents of a Q string S to a new Q string Q. So there's my new Q string Q, right? I'm just going to call assign to do all of the work of the actual assignment, right? And we'll see how assign works in a minute. Okay, so there are some issues with copy, right? So if S is a very short string, but it has a huge capacity, so your capacity might be 1,000,000, but the string might only be 1 long, right? Doing that makes an unnecessarily large copy of S, right? So here you might want to allocate an array. You might want to allocate a Q string that can hold whatever length of string S has exactly. Right, so you might want to find the length of the string held in S and then allocate that array instead. Right. String copy can be used. Yes, we're going to look at that later. All right, functions that do not alter the capacity of the string. Okay, so when you're working with lists and strings or anything that uses dynamic memory allocation, right, and you're implementing some sort of container, right? If the container has to change its size, that complicates things, right? So if you have a function and the function needs to change the size of the container, right? That that complicates things because you have to reallocate your underlying array, right? So I'm going to implement the functions that don't have to reallocate the underlying array first, right? So things like clear, right? So clearing an existing Q string, right? Turns out that's very easy to do. Right, getting a character from a Q string. So this one, we'll get to that in a second, right? Setting a character in a Q string and then removing a range of characters from a Q string, right? None of these need to change the none of these need to reallocate the underlying data array. So these are all relatively easy to implement. Okay, so what does clear do? So clear sets the length of a Q string to 0. Right? And so if you want to set the length of a Q string to 0, that's pretty easy, right? You just go in, fiddle with the length field, length member, sorry, set it to 0, right? But you have to remember that our Q string, its data array represents a proper C-style string, right? So a proper C-style empty string, the first element of the array is the null terminator, right? So you really should go in and set the first element of the array to be the value 0, right? And so clearing a Q string, pretty easy to do, right? Again, I do some rudimentary error checking here, right? If someone passes in a null pointer, then we simply return null, right? Okay, get returns a pointer to a character inside the string. It doesn't return the character itself, right? So notice that returns a pointer to car. So get returns a pointer to a character in the string, right? It returns the pointer to the character at that index, right? Okay, so this, the documentation for the function says it's checked access, right? So in other words, it's going to check to see if index is a valid index, right? When is index a valid index? So index is a valid index if it's if it's not negative. Size t is unsigned in C, right? So you don't have to worry about it being negative. So you never have to check if index is less than 0. It's never going to be true, right? What you do have to check for, though, is it greater than or equal to the length of the string? Because if it is, then that index doesn't exist, right? So if the index is greater than or equal to the length of the string, we have an error condition of some kind. So here we return null, right? Similarly, if someone passes in a null pointer to a string, we also return null. Right? Assuming someone gives us a proper index, it's easy to get a pointer to the character of that index, right? You just go into the array, you go to that index, and you return a pointer to that character, right? So the easiest way to write that in this case is to write sdata plus index. If you don't like using the pointer notation, you can write address of S data square brackets index. That also works, right? Set is exactly the same thing as get, right? So it returns a pointer to the, what does it return a pointer to? Return res. What is this going to do? Car star res. This returns a pointer to the changed character. Yes, to the changed character. That's a funny return value. Anyway, set is going to set the element at that index to that value. So to do the error checking, I'm simply going to call get, right? Get validates the index and S for us, right? And it also returns a pointer to the appropriate character, right? So I'm going to call get, right? I can simply return res at the end, right? To change the character at the given index, well, you can just go into the array at that index and set it to C, right? If you want to, you can also use pointer dereferencing here, right? So star round brackets S data plus index equals C also works just fine. All right, we're out of time. So we'll continue our discussion in the next lecture.